Section 10.2. This section is sequences. And you have your rules for taking limit laws for sequences listed in your textbook. So we're going to proceed to example 1a. It says, determine the limits of the following sequences. A sub n is equal to 3n cubed over n cubed plus 1. And since the numerator has a degree of 3 and the denominator has the same degree, we can just look at the coefficients in front and the answer would be 3 over 1 or 3. You could apply L'Hopital's to it. It would take you several shots to get there, but you would still end up with 3. Remember, the rules were if the degree on top and the degree on the bottom are the same and it's a rational function, you can just look at the coefficients in front of the highest degrees. This next one, b sub n is equal to 5 plus n over n to the n. Okay, if I look at this, I'm going to get, well, let me write it out. Oh, not b sub n. Let me write it as 5 over n plus 1 to the n. As n gets huge, because we're taking the limit as n goes to infinity, this 5 over n will go to 0, so you end up with the indeterminate form 1 to the infinity. And so we had rules for that, and the rule was that we could turn it into a natural log. So I'm going to look at it as y equals 5 over n plus 1 to the n. So the natural log would give me n, the natural log of 5 over n plus 1. And we're doing this with a limit in front of this whole thing. So let me rewrite this with the limit as n goes to infinity of the natural log of 5 over n plus 1. And so now when I look at it, this would be, I need to bring, oh, I don't want the n on the outside. N belongs on the inside. Here. If I bring the n underneath, it would turn into the limit as n goes to infinity of the natural log of 5 over n plus 1 all over 1 over n, which then gives you the indeterminate form of 0 over 0, because the natural log of 1 is 0 and 1 over a huge number is 0. So I can use L'Hopital on this. The derivative of the natural log is 1 over the junk times the derivative of the junk. The derivative of 5n to the negative 1 is negative 5n to the negative 2 over n to the negative 1 is negative n to the negative 2, which would cancel out this and this. All right, sorry about that. Okay, so then this then turns into, let's clean this up a little bit. The negative sign can come up. It cancels with the other negative sign. So I have a 5 on top over a 5 over n plus 1. And as n goes to infinity, the 5 over n goes to 0, and you end up with 5. But remember, this we turned it into natural log of y is equal to that. So you have to undo that by putting an e through. So you get y is equal to e to the 5th. And that's that answer. Let's go to part C. Part C, c sub n is equal to n to the 1 over n. Alright, so this is going to be the form infinity to the 0. So we need to adjust this a little bit. We're going to stick that natural log through there again. So I'm going to start with y equals n to the 1 over n. Then I'm going to have natural log of y is equal to 1 over n natural log of n. I'm going to turn it into a limit now. Which that would be, that's not going to work. I need to bring the n downstairs. That would turn into the limit as n goes to infinity of natural log of n over n, which would end up giving me infinity over infinity. So I can use L'Hopital on this. the natural log function turns into 1 over n, which turns into, and then that's just 1. And now the limit as n goes to infinity, that's going to turn into 0, which I have to undo, remember, because I've got that natural log of y, and it's equal to 0. Putting an e through, y is equal to e to the 0 is 1. So there's that answer. Those weren't too bad.